G'day, Michael here. I'm finding myself more and more designing things like this with basic geometrics, but to suit like a thread. As you notice, this is a 1.5 inch BSP thread, and you can see that it's tapered. Now, it's pretty easy to make a thread that's like just parallel sides, not tapered. But when you have a taper involved, it gets more and more complex. And I'm finding myself moving across to OpenSCAD to do this task. Now, I'm actually working on a heap of like filtration gear for water, and being able to make threads that fit like that does. Now this is TPU, so it's quite flexible, and so you've got to make tolerances allowing for, you know, the flexibility of the material, and also what I was predicting as a suitable thickness needed to be increased. Now, using something like VariCAD, which is the, you know, it's a typical sort of 3D modeling program, mouse driven. I quite like it. It's pretty quick to knock out engineering type shapes, and I've created quite some complex things. If you had a look at you know, my Thingiverse thing, I've got actually I'll open something so you can see what I'm talking about. Oh, actually that'll do. Open. Okay. I'm not sure. There we go. Okay, so this is a fairly complex design, and with VariCAD, it's pretty good at dialing out these sorts of designs. So looking at this, these red indicate sort of tools that I'm using for cutting. I'll just blank them off so we can see what I've actually made. Right, this is one of my Thingiverse uploads, and it's just reasonably complex. Those colours are nothing in particular, it's just the tool colour I had when I was using to put like the fillets on. I happen to have blue running, and I make the bits that I'm going to use to cut usually red as my sort of mental thing. Oh, when I'm designing this particular shape, it's to be cut out of something else, so I don't think of it as part of the design. It's okay when a design's simple enough, but when you've got lots and lots of complex shapes and things where you can't understand, it's good to colour code things just for your own brain benefit. At least that's what I find. So this is something I created in VariCAD. Now, I haven't looked at how to create this in OpenSCAD, but I actually think now there's a good chance I might be able to match it for time now with OpenSCAD. Now, the trouble with OpenSCAD is you're working more abstractly, whereas these sorts of programs, you're working almost with real, so it's more real, more tangible, because you're seeing a shape that you're creating. Let's open OpenSCAD. Over there. Oh, I can't do that way. Okay, so there's VariCAD there. Let's open OpenSCAD. Now, what am I doing? That's the one. So I might just drag that a bit smaller. Now this is pretty complex because I've got two different threads on it. There's the thread here, which is like, so I can bend this out of the road. Gee, I don't know whether you can see that. That's quite a coarse thread. It's like a 1/4 inch pitch. I'm going to show that. I don't think I can. It's like a 1/4 inch pitch. Actually, I'll just generate this. And like a 3 inch outer diameter of the thread. So it was a bit tricky to make, and it's like an Acme thread, as in it's not quite square, but it's not the same, like 60-degree angles involved. Now, unfortunately, because I've got this doing two threads, and one of those threads is tapered, the machine's got a lot of work cut out for it to do that. So I'll just leave that running for the moment, so I can move on to other things. I've also designed this part, which is basically a cap for a filtration system. Now, this is my first mock-up just to get my head around the problem at hand, and I made a gasket for it out of TPU to form the seal when it's pressed against the tank. fight. But again, that had to have that thread that I was showing you. This is the same thread, same 1.5" BSP. And the threads actually, using this method, work beautifully. They just run perfectly. I don't know whether that shows very well. I hope it does. I can't really see the thread well. Okay. Anyhow, so I'm very satisfied with the threads, how they fit and so forth. But then I needed to increase, like, this flange size. I'll pop that out of the road. I had to increase this flange size to accept some screw holes. So that's what I did. And I've added in the screw holes. The screw holes are countersunk. Right, so that's that. But I also had to make up these lugs. And there's a little bit of a, does that show? There's a bit of a, like a cubic cutout there. And that's to accept this strainer. Now I've made this the right size, but I need to make a bit of a tweak, and I'll show that in a second. The thing's still going. Yep. While that's doing that, I'll open another one. Strange. Distribute. Again, this one is fairly complex because of threads. But this is the code that I've written to create the design. So everything you see here is created by these instructions that you see here. I'm not sure I can zoom in. Can I do that? Preferences, maybe. Preferences. Increase font size, that'll do. So I have a better chance of being able to read what I'm doing here. This here is the code that's involved with creating, that design. That includes the thread, but I'll show you a little trick that's employing. With this being like a script-based design system, you've also got the ability to make a design that's like, it might be something quite complex that you can call up. You can include it in the design. And that's what this line here says, include threads.scad. Now I did not write that SCAD file. That's one, so that's come together. Okay, so there's that threaded item. Now it's got the BSP thread here. I don't know what this other thread, it's probably got a name, but I don't know what the name of it is. But that's the coarse thread that goes on to the tank. The tank's got a very, it's a very open thread, and I had to accommodate both parts. So here I've got the ability to mount to, like, it's a polyethylene tank, which has got that coarse thread, and then you've got the finer BSP thread, so I can, compatible with common basic plumbing, water plumbing fittings. Right, I'm waiting for that to come. Now, the tapered thread, I am not aware of a method in VariCAD to reduce a tapered thread at all. There may be a method, but I couldn't find anything. So, the graphics programs are great until you hit a limit of what they can actually cope with. With OpenSCAD, it is possible to create a method for creating a thread, if that makes sense. Let's open threads.scad just so you can see that. Might go to another desktop. This is getting pretty busy. Might put VariCAD on another desktop. Can I do that from here? Yes. I'm playing with a different desktop. I've just decided to play with, where are you? All desktops. That'll follow me around. Okay. What was I looking for? Oh yes, threads.scad. Might just open the folder. Again, I did not write this. This is quite involved design. It's over my head still. As I'm learning more and more about SCAD, it's making more and more sense to me how it's operating. But basically this is what is called to create the thread. When you think about the complexity of creating a thread, it's a big deal. And using this code, there's a series of like triangles that are progressively adjusted in size to make that spiral. So it's pretty neat, regardless of how complex the design is, which to the best of my knowledge VariCAD doesn't have an ability to do tapered threads. OpenSCAD has an open-ended way of creating designs. So once you get your head into how it ticks, which I'm actually quite rapidly getting my head into, you can build geometric designs, problem solvings, whatever, in here. Now people have done things like GT2 timing pulleys and gears and that sort of thing. So even actually on Thingiverse you can download things. I'm sure there's plenty of other places to download OpenSCAD files, but OpenSCAD is a really beautiful, powerful, particularly for geometric designs, a very powerful tool. Let's go back to that guy, still busy. Those threads take some time, but not only that, unfortunately the way it operates, because it has to read one instruction after the other, it can't parallelize the task of dishing up the design, because it has to finish one task before you can go on and do the other. Now let's take, for example, here we've got, you've got to kind of read this inside out. It took me a little while for the penny to drop. Here we say what we're going to do with all that's in this bracket, and so the program has to work the other way around. It works like this line, then this line, and then it will translate it that amount. Then after that it'll rotate it by these parameters, and it's a loop of those functions within those parameters. And outside that you've got these other items, and they're all joined together. In that lot you've got this English thread. Pardon me. You've got this English thread, and that is the internal thread. Might maximise that guy. And then outside of that union instruction there's this other instruction, which is rotating trap section.dxf outline is the layer. So let's just have a look at where that came from. I mentioned being able to call from OpenSCAD. We can call from a DXF file. So you can use something like LibreCAD, QCAD, whatever. So I'll just open recent, should be in there. Trap section, is that the right one? Yep, that's the right file. So where are we? Okay, so here's the two sections. Now you can obviously with CAD files, DXF files, you can enable layers. So I'll just, there's the outline. We can have a look at the gasket. So this is the gasket layer, and this is the outline layer. There's 0, 0. Okay, so if you look at those two parts, they correspond with, I don't know how well it shows up for you, they correspond with this shoulder here. You can see, I'll just turn off the gasket. So that is this section here. Does that make sense? Is that clear? Okay, and then we've got the gasket, which probably doesn't show very well on the camera. I'll just turn that off, turn that on. Now that's the section of the gasket, and that allows this to be compressible. Does that show up? Can I show it compressing? Anyhow, it squeezes in my finger. The whole idea about that is so whatever discrepancies are on the actual surface of the tank, this can compress and conform to whatever little wobblies there might be. Okay, so in any case, here I'm actually using the layer outline. So let's get that going again. Where are we? So let's turn off the gasket and just have a look at outline. So it's using that outline and rotate, extrude, angle 360 degrees. This convexity is more about how many points come together with calculations to sort of close an object. It's not like a doming, it's actually how many points can come together. As what I understand, it's the number of vertices basically can come together to make up an interpreted surface. I think that's right. Don't hold that to me. Don't hold me to that exactly. And here we're using the instruction of difference. So let's go back the other way. Difference of this item, which is the initial blank, that is the primary shape of this, that's the DXF section, rotated around to make the donut. Right. From that, we take away everything within the union bracket. So we join all these items together, whatever they are. Now all those items are, in the case of here, this cylinder here is a conical cylinder. So it's not actually a cylinder, it's like a cone with its top chopped off. Its height is 3.5 millimeters. Its base diameter is 7. Its upper diameter, is that right? No, they're radius, radii. Okay, so its height is 3.5, its radius is 7. Let's have a look at what one of those things is. Now we're creating what made that hole. It's actually a plug. You've got to think abstract here. So we're currently making an object that is the size of what is going to be that hole. So it's 3.5 millimeters high, right? Then it's 7 in the radius, so it's 14 across from there to there. And then the top bit's 3.5 radius, so it's 7 millimeters side to side. You can actually see a kind of error that I've made here. You can see that those sets of parts, they don't have the same number of items in there. Now, what I could do is dictate, let's see how quickly this works. I'm going to go, I'm going to dictate how many facets there are going around there. So, Fn equals, let's go 16, oopsie, 16 is the one I want. I'll do the same here, comma, string Fn equals 16. Now, remember there are 6 holes going around there. I've only made two edits here, but that will then get repeated around the whole lot. So let's just make that, do the process again. Hopefully it doesn't have to rebuild everything. And it's building the whole thing again. Alright, so that's going to keep it busy because it has to generate that thread. Unfortunately, I have to just wait for that to do its thing. That's done its dash. I might just close that. Right, while that's busy, what I might do is open another design. Gasket, no, open. Now, in the same way that I had that donut that created this part, I also had, in the same design, the gasket, this red bit. Okay, now this design just simply uses that gasket and makes the ring. Rotate, extrude, the angle is 360 degrees. I'll just see if I can zoom in for you. Okay. So we've got angle is 360 degrees, convexity is just a number of complexity of the intersections. The number of facets going around, I've picked 180 as my number. And it's going to use the file trapsection.dxf, which is what this one is, trapsection.dxf. And it's going to use the layer gasket. So it's simply importing the layer gasket, which is that bit. I'll just turn off the outline. So it's importing that, keeping 0, 0 as it is. And it's just going to make a ring that shape. So let's just actually run that. And there we have that. That's a quick design. And as you can see, we have that section, which is that section. So if I was to change this, let's say I do something silly. All I have to do is save that. And you can see it's instantly that new design. So there's I didn't have to change this design, I just had to rerun it because it's using this as its source for the shape. So for sections and things, you can very quickly edit them on the fly. Actually, just undo a couple. Okay, so that's back to its original design. Keep an eye on this. 6. Oops. Let's save that. Okay, so it's back to its original design. Do we have? Yes. So here you can actually see the components in it. I'll just now you can see that this is above 0. When you throw it into like the slicer, it just drops it onto the bed anyway, keeping that in the center. So we don't have to worry about the height. So I just simply disregard it and design this how it was going to be designed. So I'm visualizing it here as it would be in the section. So basically I've drawn a section of, you know, what would be cut through one side, extruded it around with OpenSCAD. So it's actually quite easy to do. Now that code is quite simple, and I tend to live on their cheat sheet. I'm starting to get the understanding of why they've done it a certain way anytime. There we go, it's the cheat sheet. So these are the instructions. As soon as you click on something, let's say you want to know something about like cylinder, it gives a very good example of how to drive it. And you can see the cylinder can be used to make a conical section. It's quite good help and quite good visuals so you can understand how things tick. Alright, well, oh yes, I'm still waiting for that guy. There was one other modification I wanted to do there too, and that is that, that's where I started in fact, this little cubic hole, geez I wish that would show better, this little cubic hole, it needs to go toward the center about 1 millimeter. So I guess while I was doing that, I might cube 612.8, that's not it. No. There he is. Here, so I'll make it minus 83 plus 83. Now here's one of those situations that is worthwhile bearing in mind. I tend to manually type in my numbers and then realize, well actually, see that 83, I can go up here and change that, and I'm going to call that one notch. Notch equals 83. Semicolons, how they denote ending the line. So I just change that out to TCH minus NOTCH, and so you can substitute any value in so you're not retyping it. Now this 84, perhaps I could do something like, let's lug, should have called that notch offset, but it doesn't matter. Let's go lug equals 84. Semicolon. Okay. Edit. Find and replace. 84 with that. Okay. Now this guy, have to change 84 to lug offset. Lug offset. 84 is 3, cube is 5, minus 3. That's what we'll do. Might even do that to it. So this lug offset -3, I made sure that ends up being a total negative figure. That's why I did that, because I've got a negative here. So I want to go lug offset -3, which will be 84 less 1, so sorry, 8, yeah, lug offset equals, oh dear, here we go, so 84, and this was to be 81, so I just have to make sure that that's the case. That's something that's worthwhile keeping an eye out for if you're doing any scripting with anything or any calculations, making sure to keep things bracketed together, that if they have to be inverted for whatever reason, they're kept together with brackets just to be safe. Alright, so let's zoom in on that, because it actually was generating while I was doing this other mod, and you can see here that there's the same number of segments going around there. Right, so what are we doing there? 5. Yeah, let's leave it at that for a moment. So I'll regenerate that just to double check that that's working correctly. And I'll just have a look at that. That's further in than it was before. I'm pretty sure that's correct. It was. Yep. So that's gone in. Yep. That's moved in 1 millimeter. So that will allow that lug, now while that shows up, focus, that will allow that lug to be in place. Alright, well I guess that's it. Feel free to like, share, subscribe, ask a question, leave a comment.